Hello everyone. In this video, we will try to understand interfacing of keypad and your LCD screen with your 8051. In previous videos, we have understood what is serial communication, how we can able to make it with 8051, what is LCD screen, how we can able to interface with 8051, what is timer, what is port, and how we can able to make use of those things and to program your 8051, how you can able to interface your stepper motor, all those things we have seen, right? So here our main concentration is going to be on keypad. So if you want to get inside your keypad, so whatever you are going to enter an input to any of your microcontroller, it is going to be through keypad. So if you want to type something inside your PC, you are going to type it with your keyboard, right? Like the same thing, if I want to connect it or if I want to give input to my microcontroller, if I want to type a program, if I want to type in data, whatever things I have to give it to my 8051, it should be through keypad. Simple representation, our keyboard, whatever we are going to have, it is going to be communicating with your PC with your serial interface, but your keypad is going to be communicating with your microcontroller with your parallel interface. So we will see that one by one if you are getting deeper into your keypad. So the question which is given in front of you is write an assembly language program to interface 4x4 matrix keypad display. So understand the word, it is matrix, right? So after that one, what are the things? So and an LCD with your 8051. So LCD also is getting connected to your 8051. Any key pressed on your keypad should be displayed on your LCD screen. That is my question. So I will be having some keypad. So it will be having some keys, something like this. If I am going to press any key in my keypad, that should be reflecting in your LCD screen of your 8051. This is what the question is. So I have already said it is going to be communicating with parallel port communication. So what is the message which you want to display in your keypad? It is going to be whatever character you are going to type inside your keypad, that should be displayed in your LCD screen. And we already seen our LCD experiment, right? Those who have not seen that video, please go to that video and understand about your LCD screen, how it is being working, so that understanding of this video will be clear. So whatever data I am going to move from your 8051 to your LCD is going to be with your port 2, right? So whatever I am going to type in terms of keypad should be reaching your port 2 so that it can be displayed on your LCD screen. So this is what our overall picture we can able to understand from this question. So before that, we have to understand what is a keypad. So keypad is a collection of keys which is interfaced with your 8051 microcontroller. In generally, it can be interfaced with any microcontroller. So it is arrangement is in the form of matrix. So I have said 4x4 matrix, right? After that, so matrix arrangement is used to minimize the number of ports. So we will try to see how it is getting minimized in terms of number of ports. So a junction of each row and a column forms a key, right? So we will understand what are those things while you're getting inside your keypad. So assume that if you are going to connect an keys to your 8051 or a switch to your 8051, how you can able to connect it? Each and every pin of that ports is going to be configured as individual switches, and whatever keys is being pressed inside your outside your 8051 is going to be replicated in a corresponding way, right? Assume that I am going to give the name of A here and B here, C, D, and all those things. So if I am going to press this key, so what we can able to understand, so this is 5 volt, so which is given to us, so it is acting as an input port. So this 5 volt is going to be reaching here, so that you are going to get the value of 1 if this key is being pressed. So that whatever 5 volt which I am going to give here will be grounded here and it will not reach your 8051. Instead, if I am going to press this key, it is going to get the value of 0. So if any of your port pin is going to get the value of 0, I can able to understand some key is being pressed. So I can able to write some logic inside my 8051. If P1.0 is going to get the value of 0, so what you can able to understand from that? So A is the character or the key which is being pressed, I can able to write inside my program of 8051. If P1.0 is 0, the character which is being typed is A. I can able to write the logic inside my 8051. This is the way how we can able to connect it if we are going to connect it in terms of keys, right? But what is a problem which you are going to face here is I am going to waste more number of ports. So if I am going to connect 8 pins of port, so if I am going to press 8 keys, so it can be from A, B, C, D, E, F, after that 0, 1 something, right? In order to have to display these characters alone, I am going to waste one complete port, which means like 8 pins, right? So if I am going to connect 8 more keys to that one, I am going to waste one more port. If I am going to 8 more pins, I am going to waste one more port. If I am going to display 8 more pins, so if it is going to be 8 plus 8 plus 8 plus 8, right? If I'm going to have this many number of keys, all the ports of your 8051 is completely wasted just to interface your 8051, right? This should not happen. So how we can able to reduce the number of ports in your 8051, even if you are going to connect and keypad to your 805, how you can able to reduce the number of ports used by your 805. So simpler logic, just have a matrix keypad. So what is matrix keypad? So matrix keypad is a display in terms of matrix. So see here, it is going to have in terms of 4, each pin or each pin can be connected with 4 keys, right? So this can be configured as your output ports from 8051. This should be configured as your input ports from your 8051. So after that, if I am going to here, from here I am going to send some signals, and here I am going to receive some signals. With this logics, I can able to understand which key is being pressed, right? If your value of A is being pressed, right? So how we can able to have, this is your VCC, or is going to be your plus 5 volt. In this case, if I am going to send the values of zeros here, assume I am going to send the value of zeros here. So if this key is A is being pressed, so what will be the value I am going to get in terms of your port 0? What is the input which I am going to get from your port 0? So if it is going to be 0, so this entire row is going to be giving with 0. So none of the key is being pressed, right? So this plus 5 volt is going to directly reach here, right? So if no key is being pressed, so I will be getting these values, right? If the value of A is being pressed, instead of this one, I will be having the value 0. This is what it means. So if I am going to say that the key which is being pressed is going to be 9 instead of A, so this is not pressed, right? So whatever the values which I am going to get here is going to be 0 here instead of your 1 here, right? This is going to be 1. So like this, we can able to understand something with respect to your matrix, but we are having logics to understand what is the key which is being pressed, right? So what is the thing which, if this 9 is being pressed, so even if your 1 is being pressed, or your 5 is being pressed, or your 9 is being pressed, or your D is being pressed, for all the things you are going to get the value of 0, right? So if I am not going to press it, the value of 5 will be directly reaching here. So if I am going to press it, so this is going to be short circuited. So the value of 5 volt is going to be reaching here, so that at the final output we are going to get the value of 0 here, right? So like this, so I am having 4 keys combination. So I can able to understand something from this one. So whether it is going to be in this column or it is going to be in this column. So if this column is being pressed, so your port 0.1 is going to get the value of 0. If any of the key in this column is being pressed, so this is going to get the value of 0. All the other ports is going to get the value of 1. Right? So as a rough idea, just have a conclusion. If I am going to give the value of 0, 0, 0, 0, so understand these are going to be your lower nibbles, right? Why I am saying it is lower nibbles? Because it is going to be data 0 to data 3 and D4 to D7, right? So I have said like it is going to be port 0, 1 to port 0 1.0, 1, 2, 3, right? So whatever I am going to concentrate is on lower nibbles. And terms, if I am going to, what are the things I can able to see here? So I am not worrying about higher nibbles. So what are the values? If I am going to have this value 1111, which it implies no key is pressed. I think it is clear now. So this is also lower nibbles. I'm not worrying about higher nibbles now. So this is also lower nibbles. This is also lower nibbles. So this is with respect to port 0 and this is with respect to port 1, right? In port 1, if I am going to give lower nibbles with the value of 0, if no key is being pressed, so whatever the value which I am going to get here is going to be F. So if any of the key is pressed, it is not equal to F, right? Two conditions. So with this condition, I can able to understand which column is going to be getting those values, right? So we will identify some logics to understand in that column which key is being pressed. As of now, we will try to understand this column key is being pressed, right? So with this, we can able to just go to our keypad and see how it is actually looking in terms of hardware. So this is your hexadecimal keypad. So you can able to see here, it is going to start from 0 and after that it is going to end at F. So the same structure, this is being used. So this is going to be in terms of your port 1.0 to port 1.3. And terms of here, it is going to be port 0.0 to port 0.3, right? So this should be configured as input port and this should be configured as output port. So all those things are same. So how many pins I am wasting here? Total 8 pins I am wasting here, which is more or less equal to one port. So how many keys I can able to represent? I can able to represent 16 keys. So in previous structure, so 8 keys can able to represent only 8 pins can represent 8 keys, right? So here I can able to say that 16 keys can be represented using your 8 pins, right? So this is the overall hardware. We can able to see it here. So in further cases, how we can able to identify the logics of which key is being pressed. We can able to see that. So we should identify a solution, right? How we can able to identify a solution. So this is just for your understanding. I will say with here. So in next iteration, so first send the value of 0, 0, 0, 0 and understand whether the value is equal to F. If it is equal to F, it says that no key is being pressed. So if it is not equal to F, some key somewhere is being pressed, right? So in next one, so we can able to understand this is with respect to if I am going to take it as 9 is being pressed, right? So whatever values I am going to get here is not equal to F. So if the value is going to be 1011, which means, so assume that this is going to be your column 0 and this is going to be your column 1, this is going to be your column 2 and this is going to be your column 3, right? Like this, we are going to have something. So from this I can able to understand the column whichever I am going to have here is going to be 1011, which means so 2, 6, A or E is being pressed. So if I am going to have a value like this 1101 in terms of your port 0, which means 159D can be pressed, right? So with this I can able to understand. If it is equal to F, no key is being pressed. If it is not equal to F, so which column I can able to be clear. So I can able to understand that. So next case, what I can able to do. So how I will send my next data? I will make your 0 here and 1 here, 1 here and 1 here. So in this case, if I'm going to give those values here, so what will be my output in terms if I'm going to make use of my pins with the values of 0, 1, 1, 1. So the key pressed is 9, right? So if I'm going to give those values here, will there be any change in terms of input, in terms of your port 0? No, because none of the key is being pressed. So what will be my expected output for these values in my port 0? It will be 1111, right? So next one. So if I'm going to give the value of 1011. So in this case, so the pin which is being pressed is 9 here, right? So here also it is going to get those values of 0. So whatever values I am going to get here is going to be again with 1111. So next scenario, it is going to be 1101. So if it is going to be 1101, what I can able to expect in terms of output? So this is going to get the value of 0. If this is going to get the value of 0, so this is going to get the value of 0. So if this key is being pressed, so this 5 volt is going to be getting here. So what I can able to get in terms of your port 0 is going to be 1101, right? So other one more combination is only there, right? So if it is going to be 1110, here is also I am going to get my value of 1111. So in this current place only I am going to get a different value, right? Just shift your zeros in terms of positions. Just find your input port values with 8051. So we can able to understand which key is being pressed. I think this makes sense now. So here how we can able to make further more things in terms of programming, we will try to understand in terms of logics. So first make all your ports to 0 and understand any key is being pressed or not. So if it says some key is being pressed, you just go to this logic. If none of the key is being pressed, just do the solution again and again. So here we are going to make use of your polling method. Always we have to watch your keypad so that we can able to get corresponding characters which is being typed. So this is your character and this is the logic. So program detects and identifies the keys activation goes on through the following stages. So make sure that the proceeding key has been released. So what it is being conveyed. So if any of your key is stuck in your previous stage, so if it is key is being pressed, none of the cases you are going to get the value of F, right? Which means every time you will be getting the value which is not equal to F in terms of your input port, right? So we have to make sure that none of the key is being stuck. So if you want to understand if any of the key is being pressed, so make them to 0, right? And after that one, so in detect which row it is being pressed, so exactly give zeros in different values and try to identify, read the columns, and we can able to understand which key is being pressed. So these kinds of things we are going to do it. So if you are saying that if it is going to be 1011 in terms of input, so how we can able to understand? So we have already seen how we are trying to see. So we can able to move this. We can able to rotate it right with carry. So rotate it right with carry. So rotate right. So this is going to be your carry bit in next iteration. So if you are going to get your carry bit here, so what is the value I can able to get here? It is going to be 0101, right? So your carry bit is going to get the value of 1. So again, rotate right with carry. So what is the value which I am going to get here again? Next iteration, it is going to be 0010 and carry bit will be 1 again here. So this is going to take the next position, right? So again, if I am going to rotate right, so what are the value I am going to get? 00 1. So at this point, this 0 is going to be moved in terms of your carry bit, right? So your carry bit is here. So this is your carry bit. So when you are identifying your carry bit is equal to 0 and you know how many jumps you have made, how many rotation rights we have made, we can able to understand which is the key which is being actually pressed, right? So we are going to rotate right with carry and we are going to identify whether the value of your carry bit is going to be 0 or not. So if it is going to be 0, which means I can able to say this key is being pressed. So while getting into programming, we can able to be little more clear on this topic. So in terms of flow chart, we can able to see, first start, ground all your rows, which means give all the values of your output ports to 0. So read all the columns. If any key is being pressed, yes, go to 1, no, just iterate the loop. So this is going to be your polling method, right? So always we are going to wait for your inputs from your keypad. So after that one, if any of your key is being pressed, read the column. So read all the columns. If any of your key is being pressed, yes, go to this one. So in terms, we are having a concept called as debouncing in our keypad. So if you are going to press the key, so what you can able to expect, so if that key is being pressed, it is going to be giving an input like this, right? At the stage, if I am going to press that key here and if I am going to release this key here, I am going to expect a signal like this, right? But actually we will not get a signal like that. So instead we will be having some other signal. So since without your debouncing condition, so we will be having some errors here. So if I am going to press this key here and I am going to release the key here, I am having this debounce condition due to your static electricity. So this debounce condition, so this is going to be having an impact. Actually, if I am going to say that the key which is being pressed is A, right? So A should be for a long duration of time, but actually it will not be like this because of static electricity. This is going to be having a debounce condition. So how we can able to eliminate this debounce condition? So as like we are going to connect an capacitor to that one, so capacitor is going to be gradually charging and it is going to be reaching its maximum point and we can able to release this one, right? So the same thing, so we are having an capacitor so that the connected capacitor can able to charge slowly and it reach its maximum and after that it is going to give it. So finally from this also I can able to understand this is the character A which is being pressed till it is going to cross the level of that exact points. So we have said like it is going to be 0 to 0.8, right? And after that 2.5 to 5 volts in terms of representations of zeros and ones in your 8051. So since it is crossing the values of 0 to 0.8, the value whichever I am going to have get here is like no key is being pressed. And after it is going to reach the value of 2.5 to 5, which means like the character A is being pressed. I can able to understand that because of this debounce condition, right? So this debounce condition, we have to create a small delay. So nothing is needed in terms of your programming. From here to here, I will just create a delay. I will not try to read my inputs during this delay condition. So I will just try to create a delay so that whatever values I am going to read from my keypad will be after this delay. So after this delay only, the values whichever I am going to get here will be read. So it will not say that A key is not being pressed. So after this delay only I am going to measure, right? So defaultly I am going to get the value of A, right? So I can able to avoid this debound condition. So for that I am going to wait for some duration of time. So read all the columns and after that no key is being pressed. So ground the next row. We have already seen grounding means I am going to make that row to be 0, right? 0 1 1 1. After that it is going to be 1 0 1 1 and after that it is going to be 1 1 0 1 and after that it is going to be 1 1 1 0, right? So this loop is going to continue so that we can able to identify which key is exactly being pressed, right? Okay, so we have come to an interfacing point. So I'm going to interface this keypad, hexadecimal keypad, using these parallel lines, and I'm going to connect it to my 8051. So this is your 8051. We have seen a lot of experiments. So this is your keypad. Like this, I'm going to connect it. So whatever I'm going to click here in terms of keypad. So if I'm going to click the value of 0 here, A here, so A should be displayed in terms of your LCD screen. That is what my objective of this experiment, right? For this, I have to write a logic. So those who have not seen your LCD experiment, please go back and see your LCD experiment and come back here so that we can able to understand a little more on this topic. So this is your program. So this we have already seen. So your interrupt ISR routines is going to be from 0 to 23, right? So I'm going to jump this location. So if I am not going to jump this location, it is going to create an error. So My program starts with 0, 0, and after that I'm going to jump to start here. So we have seen so many things with respect to that. So we can able to go through your previous videos and we can able to see how it is being done. So we know that port 0 should be configured as input port, right? Why? Because port 0 here, it should be configured as input port, right? And your port 1 has to be configured as output port. So if you want to configure that as input port, so it should be getting the value of FF. We have seen in our ports experiment itself. So FF will be given to your port 0 so that it will be configured as input port. And after that, I am initializing my LCD screen. So it is going to be called as a subroutine. So in our LCD experiment, we have already seen initializing your LCD screen, right? So we have done that experiment. So again, we will see what I am going to do in terms of my LCD initialization also. So it is in subroutine, right? Somewhere on backside of my program, I have created this subroutine. I have written a program for this subroutine. So that will be called as a function kind of thing. So that is going to be called as a function, and after that we are going to use it. So as of now, try to understand your LCD is being initialized. So port 1, it is going to be configured as output port, and as well as we have to make sure that every values we are going to get in terms of ports should be getting the value of 0, 0, 0, right? At first point, we have to make sure that none of the keys is being stuck, right? So these values, I'm going to give all the port values with 0, 0, 0, 0. So port P0 is going to get those values, right, as an input port. So move that value, port 0 values to your accumulator. So I'm going to AND operate with your accumulator with 0F. So why I'm doing this one? Because so port 0 is going to give some values, right? So port 0 is can able to give a values with respect to 1111, or it can able to give some other values also, right? But this is fine. So this is with respect to D0 to D3. That is fine. But we are having your higher nibbles also, right? So we can't able to compare only your lower nibbles. So we should be comparing along with your higher nibbles also, right? So I have to make sure every value here is going to be having the value of 0. So how I can able to make sure that if by mistake or some other program is accessing your port 0 so that there is higher nibbles are being used. So how I can able to make it? So if I am going to make an AND operation, so assume that this is the key which is being combination of input which is being pressed. So I can able to expect my input in terms of 1011, right? So 0, so I don't know whatever values I'm going to have here, right? So it can be 0, 0 or it can be 1 also. So if I'm going to make an AND operation with respect to your accumulator here. So AND operation, it is going to have 0, 0, 0, 0, 1, 1, 1, 1. AND operation, your 1 and 1, it is going to have the value of 1. So it is going to be an AND operation, right? So just check with your AND truth table. So 1 and 1, it is going to have your 1. 1 and 0, it is going to have your 0. So 1 and 1, it is going to have the 1. So if it is going to be having some other values also, port 0, some other programs is trying to access this one. Instead of this one, if I am going to get the value of 1 also, if I am going to do the AND operation, all the higher nibbles can be converted to zeros. So if I am going to make an AND operation with respect to 0, 0, 0, 0, 1, 1, 1, 1, correspondingly higher nibbles I can able to make sure everything will be 0 so that my comparison will be easy, right? So I am doing the operation of AND to my accumulator so that 0, 0, 0, 0, 1, 1, 1, 1 is given in terms of ANDing so that my accumulator values, higher nibbles of my accumulator values will be maintained with the value of 0. So nothing is going to be disturbing my port 0. So just compare your accumulator value with the values of 0, 0, 0, 0, 1, 1, 1, 1, which means 0F, right? So we already seen. If F is given, if A is not equal to F, what it implies? Some key is being stuck. So check all the keys whether it is released or not. If it is not released, what it has to do? It has to iterate it loop again and again here, right? So some key is being stuck, your keypad program should not work. So unless otherwise you are going to remove that key which is being stuck, it will be iterating in this loop itself. So I am going to compare with 0f. So if it is being pressed, which means it is not equal to f, right? So if it is not equal, jump, iterate the loop again and again till it is becoming that one. So after that one, since it is going to be taking for very less number of cycles, we don't know whether it is happening or not. That much faster your processor is going to compute, so that it is going to check previous instant itself some key is being pressed or not. Wait till it is becoming f, right? If it is becoming f, come to the next program, right? Next line. So I am having a delay here. So why I am having delay? Because so every instant of time I have to make sure that I am having a 20-second delay, 20 millisecond delay. 20 millisecond delay for every case I will try to call it, because so the time duration, time delay which I am going to have for pressing the keypad can be more than 20 milliseconds, right? So for that understanding, I will try to call my delays in every instant of time. So again, so if the values are being pressed, so it is going to check P0 is going to move the value here, and after that I am going to AND operation with your accumulator, same process which I am going to do here. So after that one, I am going to check whether this value is equal to 0f. If its value is equal to 0f, so which means jump not equal. If it is not equal, accumulator is not equal to 0f, which means some key is being pressed here, right? So if some key is being pressed, just go to that one, right? So if some key is not being pressed, so what it has to do, it has to jump again to K2, which means with the help of polling method, I am going to iterate within here itself. So I am waiting for my key which is being pressed. This makes sure of polling method, right? So if any of your key is being pressed, it will jump to over. If the key is not being pressed, it will be iterating within this loop itself, right? So with this, I can able to come to, if some key is being pressed, it is going to be jumping here, right? To over. That is what we have seen here. So it is going to be jumping here. So I have said like debouncing condition will occur, right? So I have to wait for some duration of time. So I am calling my a call delay. A call delay is an subroutine. We have seen many programs with respect to subroutines, right? So in our timer, everywhere we have used our a call instruction. Just go through that. So it is also a subroutine which can able to create a delay of 20 milliseconds so that it can avoid its debounding condition. So after that, I am going to push the value of P0 to A accumulator. So check whether the key is being closed. So I am going to compare this condition. So if this condition is going to be satisfied, which means it is not going to be used. So if this condition is being satisfied, so I can able to make sure of so same operation everywhere. I will be making the same operation. So where I am going to make it with respect to 0. So if it is going to be 0, it is going to be coming over here, right? Like that, I can able to jump out of that condition. So I am making sure. So this is making sure that if none of the key is being pressed at the initial point of time, this is going to make sure that this is going to make sure that none of the key is being pressed at initial point of time. So this is going to make sure that it is crossing your 20 millisecond delay. This is going to make sure that it is crossing your 20 millisecond debouncing condition, right? So this is going to make sure of that. So after that one, so this implies some key is being pressed, right? So if some of the key is being pressed, I can able to give the values, right? So I can able to give the values of what I have said. So it should be having 0, 1, 1, 1, 1. So after that, value should be 1, 0, 1, 1. After that, 1, 1, 0, 1, 1, 1, 1, 0, right? So first, these values I should give, right? So these values are here. So higher nibbles I don't have to worry, because I am doing an AND operation anyway, it is going to become 0, right? So I can able to give it as 0 or I can able to give it as 1. Anything is fine for this condition. So 1, 2, 3, 4, 5, 6, 7, 8. So one more 1 should be there, right? Yeah. So it is going to check for that, and after that I can able to give those values. So it is going to give those values to your P1. So P1, this is your P1, right? So here I am going to give these values to make sure which key is being pressed, right? So if that thing is going to happen, so which key is being pressed, I can able to understand. So if it is going to be the port P0 is going to get some values, and this is going to be moved inside your accumulator. So here I am going to check whether it is equal to 0F. 0F means 1111. 1111, which means and that particular row, none of the key is being pressed, right? So if it is not equal to, so this is not equal to 0F. If it is not equal to 0F, so if your accumulator is not equal to 0F, which means the row 0 is being pressed. Some keys in your row 0 is being pressed. So this is with respect to row 0, row 1, 2 and 3, right? So this is with respect to columns. So from this, what I can able to convey an information, if it is not equal to 0F, which means some key in row 0 is being pressed, right? So I am going to imply that one. So if it is not, which means if it is going to be 0F, so none of the key in row 1, row 0 is being pressed. So I have to check for my next condition. So this is my next condition, right? So I am going to give this input. So correspondingly, I am going to read my P0, P0, and I am going to give it to my accumulator and operation with my higher and lower variable, so that I am making sure the next portion which I am going to get is going to have the value of 0. So after that one, if this is not equal, so which means A accumulator is not going to be equal to 0F. So this implies I'm going to give the value of 1101, right? 1011. So reverse conditions, right? Which means row 1 is being pressed, right? So next condition 1011, next condition 110111. So all those conditions, this is row 2 and this is row 3, right? So I can able to assume these conditions. If none of these conditions is satisfied, I have to again jump to K2. I'll jump K2. K2 is here, right? So it is going to be jump back to this position itself, so that it is going to wait for the next key is being pressed, right? So if it is lying in any of the condition, it is going to jump for that specific condition, right? So if it is going to be row 0, so this is going to jump to this row 0 memory location, right? So in row 0 memory location, so I am just pointing my DPTR to code 0. So what is code 0? So this code 0 is here, right? So code 0 is going to have the values of 0, 1, 2, 3, like your table, lookup table. So I can able to have these values here. So I can able to make sure that the values whichever is being pressed will be 0, 1, 2 or 3. That is confirmed. So if your row 0 is being pressed, any of your keys from this one is only pressed, right? So if your row 1 is pressed, so DPTR is going to point to code 1, right? Which means 4, 5, 6, 7 is being pressed. So in this condition, if it is going to break its loop, so it is going to come here. So code 2, it is going to say that 8, 9, A and B are being pressed. So if it is going to be row 3, it is going to make sure that your key which is being pressed is C, D, E, F. So this is with respect to your inputs, right? So after that one, we have identified the logic, right? Rotate right with carry, or whether it is going to be in terms of your accumulator, right? So till now we have identified whether it is equal to F or not equal to F, right? 0F. So in which key is being pressed? If I want to make sure of that, so rotate right with carry. So assume that your key which is being pressed. So here whatever key which is being pressed is going to be your, sorry, this is your row 0, right? So I have given in reverse order. Row 0, 1, 2 and 3, right? So if your key A is being pressed, so this is going to be getting condition row 2, right? So A is being pressed, so this row 2 is going to be activated. So if this row 2 is getting activated, it is jumped to this row 2. So in this row 2, we can able to identify, this is with respect to your code 2, right? Code 2. So in this code 2, it can be 8, 9, A or B, right? So actually I am pressing this value of A. So I have identified in which row the key is being pressed. And after that one, what I can able to get it conveyed. So which one is being pressed? I have concluded like which is not equal to F, 0F, right? So but the value inside my accumulator, so if it is going to be with respect to A, see here, with respect to A, so this is with respect to 0, 1, 2, 3, right? So in this condition, if it is going to be 0, 1, 2, 3, what will be the values which I am going to get here? So it is going to be your port 0. So it is going to be your condition. So correspondingly, which things I am going to get it in terms of your input. Correspondingly, I can able to get it clarified. So what I can able to expect. So if it is going to be values, so whatever values I am going to get here is going to be 1101, right? If your A is being pressed, right? So rotate right with carry. So what it is going to see, initially you make your carry flag to 0, else it is going to be default with respect to 0. So whatever values I am going to get here is 1101, which is not equal to 0F. Till now I have checked for this condition. So if this value is going to be 1101, so we can able to see here, right? So 11, if this is pressed, it is going to make it to 0 and this is going to be 1, right? So correspondingly, I am going to get the value of 1101. So rotate right with carry. So it is going to rotate right? So in this, what it is going to do, so previously I have already AND operated, right? 0, 1, 1, 0, and after that it is going to carry is going to get the value of 1. Jump no carry. So now the carry flag is set, right? So it will not jump to match. So it is going to again within this loop itself, it is going to iterate it. So increment your DPTR. So DPTR is here. So DPTR is going to point to your memory location. So incrementing your DPTR. So DPTR is going to have your value of your code, right? Your DPTR is going to point that one. So incrementing your DPTR, and after that one, yes, jump find. So find, again it is going to jump back here, right? So DPTR, initially it can able to be having the value of 0. So now incremented, your DPTR is going to have the value of 1 here. So it is going to jump back to again here. So rotate right with carry. So in this condition, it is going to be 0, 0, 1, 1. So now your carry flag becomes 0, right? So if it carry flag is equal to 0, it is going to jump for match, right? So your match is here. So if your key is being pressed is not equal to A, it is going to be 9. So it is going to wait for one more iteration. So it is going to be incrementing my DPTR. So the next value of 2 also, 2 will be getting inside my DPTR, right? So what this instruction will do. So already in terms of your accumulator, I am having some values, right? So if it is going to be accumulator plus DPTR, clear your accumulator, right? So I have cleared my accumulator. So 0, 0 is there. Plus your DPTR is value is going to be 0, 1, because this is the value which I have identified, right? So memory location is going to be 0, 1, right? So if it is going to be 0, 1 in that condition, how it is being done? So if it is going to be 0, 1, so A call delay, so I can able to understand, I am going to put that data specifically inside that LCD data. So while seeing your LCD program, we have understood that it is going to be LCD data, right? So in terms of pointing, it is going to be 0, 1, 2, 3, right? So in this case, so it is not equal to B, so that in first iteration it will not be giving its value. So the value, if it is going to be having the value of 1110, so the character value of B is being pressed. So if it is going to have the value of 1101, the character value of A is being pressed. So if it is going to be having the value of 1011, so the character value of 9 is being pressed. So if I am going to have the value of 0111, your character value of 8 is being pressed. This is the logic, right? So first we are trying to understand whether it is not equal to 0. After understanding if it is not equal to F, 0F, so we can able to come here and we can able to identify on which position 0 is being located. So for understanding this, I am rotating right with your accumulator, so that we can able to understand exactly in which position your 0 is being placed. So after getting that 0th position, I can able to display that value there, right? So I am going to create a delay, right? So I have said that your delay should be having 20 milliseconds, right? So you can able to make use of your timer. for creating a 20 millisecond delay, right? You can able to use any timer modes and you can able to do that operation. Else, if that is not needed, you can able to use this simple timer in terms of iteration. We have seen many things with respect to timer, right? So you can able to make use of creating delay without timer also, but approximately it should be equal to 20 milliseconds. So after this one, so LCD initialization, we have already seen about this one, right? So LCD initialization 38, what it is going to apply, it is going to be 16 cross 2 LCD, and it is going to have 5 cross 7 lights. So if it is going to be 0E and if it is going to be 01, so all those things. So LED, so your LCD display on plus cursor on. So this is going to be clearing your LCD screen, and this is going to be your right hand side movement. And in terms of 80, which means it is in, so I'm having two columns, right? In terms of your LCD screen, I'm having two rows. So 80 represent, it is going to be in first row, and 0 represent the digits which I'm going to type here is going to start from here. So we have seen all these things in your LCD program. If it is going to be data, so my data pin of your LCD is getting connected to port 2, right? So whatever value I am going to have in terms of your accumulator, that should be moved inside your port 2, right? Because previously I have moved those values, right? So I have moved those values inside your accumulator, right? So corresponding values. So in terms of memory location, if it is going to be 0, B is being moved. If it is going to be 1, A is being moved to the accumulator, right? So if A is being moved inside your accumulator, so whatever accumulator value, that should be given to your port 2 so that the data is going to be having. So set 3.7, clear 3.6, all those things we have seen. Just go through your LCD screen experiment so that you can able to understand it. So here also we need a delay of 3.5, and after that clearing. So you have created from high to low pulse, right? So I think you remember all these things. Just go through your LCD screen program so that it will be easy for you to understand. So if it is going to be your, this is for LCD data, and if it is going to be for LCD command, right? So you have to push that value of your LCD command inside your P2 so that we are going to instruct, right? So this is going to be your LCD command. So LCD command is going to be pushing that value inside your port 2, and after that, correspondingly, what is the change we are going to have here is just this one for your LCD command and your LCD data, right? Instead of set byte, I'm going to give it in terms of clear B 3.7. Only this change we are going to make here. So all these things are same as your LCD experiment. So from this, we can able to understand like the programs for your movement of data from your keypad to your LCD screen, right? So this is your program. So overall, we can able to come to an conclusion. So I'm going to connect it with parallel ports with respect to port 0 to port 1. So here I can able to connect it with your keypad to 8051. So after that one, I am trying to neglect your interrupt locations. I am jumping here. So my port 0 should be your input port, and my port 1 should be your output port. Along with your output port, first initially I have to send the value of 0000. So these are the logics, right? So first push the value of 0000, and after that try to identify whether the value which you are going to get here is going to be 0f. If it is equal to 0f, which means none of the, which means like some key is being pressed, it is being stuck, right? So after that one, if it is not stuck, so come to this one. So here again I am going to check that condition. I am using an AND operation here because I have to make sure your higher nibbles will be always equal to 0. So after that one, I can able to get inside my checking condition. If my accumulator is going to be equal to 0f, which means some key is not being pressed in that row. If that is not equal to 0f, which means something is being pressed, right? So with this logic, I am trying to identify it, and after identification, if some key is being pressed, I have to push the value of 0111, and I have to push the value of 1011. After that, I have to push the value of 1101, and after that, I have pushed the value of 1110. So that correspondingly, I can able to check which row is being pressed. So corresponding row elements will be moved here. So if I am going to move that corresponding row elements here, so correspondingly the DPTR value is going to point to your code. so that if it is going to be 0, it is going to take this position. If it is going to be 1, 2, 3, corresponding positions is going to be taken here. So it is going to be pointing your K code. Correspondingly, the rows elements has to be jumped here. So after that one, in order to identify which key is exactly being pressed, rotate right with carry I am going to make, and after that jump no carry. It is going to check for its match. If it is going to be matched, clear and load the data inside your A. If it is not matched, incrementing, keep on incrementing your DPTR, so that it is going to be jumping from 0, 1 to 3. Correspondingly, the next elements is being selected. So at this point, when the 0 is obtained at your accumulator, or 0 is obtained at your carry flag, exactly that is the key which is being pressed. So move that value of DPTR. So the corresponding value of DPTR is going to be loaded inside your accumulator. So after getting that value inside your accumulator, I can able to send that value to your LCD screen, right? I think this makes some clear sense in terms of understanding with respect to your 8051 interface with your keypad and your LCD screen. So now we can able to directly enter inside your real-time interfacing. So on the right hand side column, we can able to see the LCD screen plus your 805. So this is the same program I have given in terms of Keil. This is for jumping your interrupt locations. This is for configuring your P0 as input port and P1 as output port, and pushing the value of 00 inside your P1. So actually it can be 00H also. So anything you can give. So all those programs as like I have given in the same way I have given here also. So after this one, so for jumping your exact rows, I am going to use your K code. And after that, to identify which key is being pressed, I am using this logic. And after that one, I can able to move inside my LCD screen commands, right? So we have already seen. So with this LCD screen command, what I am trying to convey? So I am trying to convey like in this place, exactly at first row, first element, it is going to be starting its display. Whatever key I am going to press here, those values will be coming in this display one by one. That is what the command in terms of LCD says, right? So this is your connection. So just I can able to give the power supply. So this is your USB from your PC, and this is your power supply, and this is your LCD screen where you can able to see your display. So this is your keypad, and this is your connecting cable, so that it can able to communicate in terms of parallel communication to your 8051, right? So I can able to save this program, and I can able to run that program. Come to debug mode. So after that one, you can able to, if you want to see your outputs in terms of port 2 and port 3 also, you can able to see that. Port 1, port 2, plus port 0 and port 2, right? So these are the pins which is being connected, right? So all these things we can able to have this connection. So I can able to run it, and I can able to see, I'm going to see the expected results here, right? So I can able to run it. So your LCD is getting connected. So see here. So it is going to start its character. So it is an polling method. So it is going to keep on wait till I am going to press the key, right? So if I am going to press one key, correspondingly your port 2 values is going to be changed, and correspondingly you can able to see that values inside your LCD screen. So if the value of A is being pressed, so you can able to see the value A, right? But this is going to be very faster, right? So I can't able to see in terms of port pins, but I can able to visualize in terms of our LCD display. So A I have pressed, it has been interfaced, so that corresponding logic is identified. So 5 is being pressed, so 5 is being pressed here. So 0 is being pressed, I can able to see 0. So all these things in terms of your hexadecimal display. So correspondingly I can able to press any keys. It is going to be correspondingly giving those values exactly in the way. So this logics. So I have to create the truth table, and I have to say if this key is being pressed, so corresponding, if this key is being pressed, the corresponding in terms of your port 0, it is going to have the value of 0 here. So the pin has to be analyzed, and after that it has to be compared with your 0 flag, carry flag, and that carry flag has to be like this port has to be understood, and after that it has to be jumping right to your carry flag. From that carry flag, we can able to understand which key is being pressed. For that, I have to understand the logic. I have to write a lookup table. So that lookup table, whatever we are going to see here, is there. Right, we have seen, right? So this is your final lookup table. Final lookup table with respect to your output, we can able to see. So dptr is going to be correspondingly having with the value of k code. So what are the things we can able to see in terms of k code is here, right? So these are the values in terms of k code. Like this is your lookup table. So the lookup table is being created. So from that, it is going to be jumping to the memory location of rows. From that, we can able to make that dptr to be looking to that lookup table row or on that lookup table, and from that we can able to understand which key is being pressed by rotating right. So like this, we can able to interface any keypad with your 8051. It can be 2x2, it can be 3x3, it can be 4x4, any kind of things. Correspondingly, your input pins is going to increase or decrease. Correspondingly, your output pins here is going to be increasing or decreasing. So this is your port 0, this is your port 1, which is getting interfaced with your 8051, right? So if you are going to press my reset, it is going to be coming back to my previous one. So this is your programming of interfacing keypad with your 8051. So in next lab, we can able to see further interfacing experiments one by one. Thank you for your patient listening.